Thank you very much for that introduction, and good morning, or it's good evening where you are, of course. Thank you for giving me such a vast canvas to talk about. What I hope to do is to point to a few directions which I think are of critical importance. Some of them have come up in the presentations that I've been listening to, the excellent presentations that preceded this keynote. Let me first share my screen and make sure that we can do that all right. And are we good with the screen? Good. Okay, so I've called this Perspectives from GIScience and Volunteered Geography. And what I'll do is spend the next half hour talking about some of the issues which to me arise in some of the work we've heard about, and which are worth bearing in mind as you explore this area of research. And I'll tie it as much as possible to climate justice and the smart city and sustainability. So first, some definitions. These I think are important because there's a great deal of confusion over what some of these terms mean. So the first, GIScience. To me, this is the science behind GIS, the principles that are true of geographic information and implemented in GIS. And I'll talk about some of those principles. And critical thinking about GIS and its societal impacts and its ethical issues. And just recently, I've been especially focused on the ethical issues, of which there are a huge number, in part because of what has happened during the pandemic with some of the explosion of research and very rapid research into the dynamics of the pandemic. And then volunteer geography. And my interest in that, which you referred very kindly to from 2007, knowledge of the geographic world that originates with volunteers and the general public. And I've added the general public there because it's not necessarily always the conscious volunteering of information which leads to crowdsourcing. So we'll get into that in a moment. I put this in too because I want to use it as an illustration of how I believe we should question assumptions. And in this particular case, the assumption, of course, that the North Pole is at the top of the Earth. This is, I still find a very disturbing picture. To see the Earth without the North Pole at the top is for some reason, quite disconcerting. So let me start with volunteer geographic information, or crowdsourced geographic information, or crowd mapping, whatever term you prefer. And my interest in this back in 2007 was motivated essentially by the cost of geographic information and copyright restrictions. And this was particularly important in the United Kingdom, where all geographic information produced by the Ordnance Survey was, and still is, subject to Crown copyright. In other words, it's the property of the Crown. And Stephen Coast, who was a grad student at University College London at the time, developed the program we now know as OpenStreetMap, which has had an enormous impact, replacing in many ways government-produced data, as accurate in many ways as government-produced data, and something that's, of course, come up already in the discussions in this session. But also, and I think this is perhaps more important in the long term, that volunteer geographic information is a response to delays in acquiring knowledge using conventional means. And this came home to me very clearly in the Banda Aceh tsunami, which occurred in, I believe, 2004, in which it was perfectly clear that conventional ways of gathering data, particularly remote sensing, were falling well behind in providing information about the extent of the damage. And if you recall the precise details of that event, it was 3 days before the world at large became aware of the devastation that had been produced in Banda Aceh. And to me, there was a paradox here that we had people on the ground fully capable of telling the world about the disaster. And yet we waited for 3 days for information from satellites. And that, of course, is in part because we have to wait for the overpasses of the satellites, and in part because Indonesia is very frequently covered with cloud. So we have here, I think, an explosion of interest in real-time data, a lot of it crowdsourced, for the smart city. And real-time data in combination with the Internet of Things, in other words, data that's coming from sensors. So quite rapidly in the past decade or so, the whole world of GIS and geospatial data in general has moved sharply in the direction of real-time, rapid response, and knowledge that's acquired almost in real time. So perhaps rather than the first, the economic arguments for volunteered geographic information, perhaps it's the speed that is perhaps the most valuable of its properties. So here's just an illustration of the devastation in Banda Aceh. This one eventually acquired from an aircraft, and again, some days after the event. So just to illustrate the huge success of OpenStreetMap, here is Port-au-Prince, and this was the state of data prior to the 2010 earthquake in Port-au-Prince. And this was very quickly augmented by volunteers all over the world who produced this. Quite accurate and very dense information of value, enormous value, to the relief effort. Now, if you look closely at this image, you will see that many of the streets are labeled no name. And of course, the names of streets are not visible from space. So the only way to find out the name of a street is from humans. And many of the groups working on this using imagery supplied by companies such as Google, many of the people working on this were able to access Haitians who were familiar with Port-au-Prince and were able to supply the names of many of the streets. But in other cases, streets either did not have names or no one could remember and no one was available to remember the name of the street. So let's think about some of the issues as you get more and more engaged in crowdsourcing, in crowd mapping. First, who volunteers and what do they consider worth mapping? Why do people volunteer? And this has been a remarkably important question as OpenStreetMap has developed. Why is it that some parts of the world are much more densely mapped in OpenStreetMap than other parts of the world? And it's notable, for example, that Germany is well ahead of other parts of the world. What does that say about Germans? What does that say about people volunteering for mapping of German data? Indigenous mapping, because indigenous cultures typically, the things they consider mapping are very culture specific. And so it may be quite difficult to engage indigenous populations in mapping the things that other cultures consider important. Also land ownership, and we've seen some, in fact, quite critical situations develop over different cultural practices with respect to land ownership. What does it mean to map land ownership in some cultures? It's a very difficult question in many cases. And then what about information that's not visible from space? There is very little information that we can use to add to augment what we can see from space. Occasionally buses have numbers on their roofs, occasionally emergency vehicles have numbers on their roofs, but in general, we don't put barcodes on top of buildings so that people can identify them from space. And then very significant question of updating, because a lot of the motivation for projects like OpenStreetMap is in the initial creation of a map. It's not in the updating and correction of a map. So that, again, becomes a significant issue with volunteer geographic information. And then finally, information from people who do not opt out. And this is a problem which is developed with many apps, many smartphone apps, which invite people to contribute information, but in fact, don't make it perfectly clear that they are capturing information at great levels of detail and aggregating and reselling that information. In fact, there's now a large industry, certainly in the United States, that's built around information which users of apps have some, in many cases, unconsciously provided information about the locations. And here's an example. This is a data set of 300 million pings, or point records of location. And these are the locations from one device. Now, these data are anonymized. There's no identification of the individual. There is only a coordinate and a device identifier. But if you sort all of the pings generated by one device, you get something like this. This is one person, presumably, unless that person has lent his or her cell phone. These are 8,600 pings over a period of 4 months. And unfortunately, it is trivial to infer where this person lives, where this person goes to see a doctor, where this person's boyfriend lives, and an enormous amount of personal information is very easily inferred from this kind of data. This kind of data is typically generated from an app. And if the user of the app, when the user installs the app, if the user is really interested, they can certainly peruse the 100 pages of terms and conditions to find out what will happen to their data. But of course, most people don't do that. Here's, in fact, the New York Times, who originated this article, identified the person, contacted the person, got their agreement to be revealed in this way, and there's the person's house inferred from this data set. So this is a very rapidly growing and I think very scary unintended consequence of crowdsourced geographic information. And before we get too excited, here's an example from one person. This is one person's tweets, each of which are georeferenced, and each of these red dots is where this person tweeted from. And this evidently is someone who attends California State University, Los Angeles. But look at the spread of the dots. And what you can probably infer from this, and I think correctly, is that these are errors in the location information captured by the cell phone. So before we assume that information which may be available to 5 or 6 decimal places of latitude and longitude, before we assume that it is accurate, I think it's important to question what the accuracy really is. I wanted just to make one last point about VGI, and then I'll go on to GIScience. And that's a question of epistemology. What do we learn from crowdsourced geographic information? And here's the problem, because suppose we crowdsourced a lot of geographic information and discovered something of a social nature, something about human spatial behavior, which conflicted with our previous understanding developed from conventional research. Would we believe it, or would we blame it on some aspect of the sampling or the analysis? So is crowdsourced geographic information limited to confirming what we already knew? I think this is a very serious question. It's a question that, in fact, arose in the discussion after a series of 20 papers on VGI some years ago. And it's something that doesn't only apply to VGI, because you can ask the same question about many of the newer sources of data. All of them have questions to some extent. And in every case then, they raise doubts about what we appear to have discovered. So going back to our previous point, it seems that the real advantage of VGI may not be epistemological. It may be because of its near real-time benefits, the enormous practical advantages that come from having data which is almost instantly available. So now let me turn to GIScience, and the central question, I think, for GIScience is always this: is spatial special, or what is special about spatial? And one very simple answer to that question is that methods developed for non-spatial information often fall apart when the information is spatial. So the spatial nature of data often makes it impossible to pursue traditional methods of analysis. And one reason for this is what we term spatial dependence. So spatial is special because of spatial dependence, because nearby things are more similar than distant things. That means then that a sample of people from an area will not be a random sample of the world's population, that the census tracts of Los Angeles are not a random sample of some imagined population of census tracts. Inference then from spatial data is always fraught when inferential methods are being used. Now, of course, there's a huge literature on what we can do about that, but it does, I think, to me, make the point very, very forcibly that spatial is special. Here's a little example. This is southeastern England, and the variable being mapped here is the percentage of population that is over 65, old age pensioners in British terminology. And you can see that London, for example, all of the reporting zones in London illustrate the scarcity of older people within London, particularly central London, and the abundance of older people around the coastal resorts of Eastbourne, Bognor Regis, Bournemouth, Clacton. Then a second principle, and I'd suggest also important in many ways, is that the geographic world exhibits uncontrolled variation. This is what we term spatial heterogeneity, and it implies that there is no average place on the Earth's surface. We cannot regard anywhere on the Earth's surface as average. But the most important implication is that it is very difficult to generalize results from one part of the Earth to the rest of the Earth. What we discover about one part of the Earth is very rarely generalizable in any useful way. That's, I think, a very frightening conclusion. It suggests that a lot of the research that we do in the geographic world is basically place-based and becomes very difficult to generalize. And here's one of the reasons for this, and it's again, an unintended consequence. This is the Yucatan Peninsula of Mexico and Guatemala and Belize. And this is soil mapping, the soil data sets that have been developed. And you can see that the boundaries, the political boundaries of Guatemala and Belize appear very strongly in this data, even though soils, of course, do not change at political boundaries. And also the states of Mexico show up very clearly. Quintana Roo in the top right is clearly very different from the rest of the country. This is, of course, a variation in soil mapping practice. It's not a variation in soils. And that's something that comes back to haunt us in many areas of geographic research. It's the reason, for example, for the INSPIRE project in the European community, which has attempted to flatten out some of these differences that arise because of local practices. And here's an example that I like to use, which I think illustrates this principle very, very clearly. This is the state of Mississippi, and it's a plot of the counties of Mississippi. The vertical axis is the median value of housing. and the horizontal axis is the percent of the population Black. And you can see that there's clearly a negative relationship here. The counties with a higher percent of African Americans have a lower median value of housing. And as a good social scientist, you might argue that this is a useful conclusion, and we should apply this in practice to the rest of the United States. However, if you were to repeat this analysis in the state of California and the counties of California, the same two variables, you would find, in fact, that there is a positive relationship in California. And here's a perfect example of a lack of generalizability, the spatial heterogeneity, which underlies any analysis of anything geographic. I've recently advocated that we should recognize another effect as a key effect in GIScience, and we should call it the Openshaw effect, in honor of Stanley Openshaw, who died earlier this year and was the originator of this. It's something we have called the modifiable aerial unit problem. And I've always thought that's a rather awkward and misleading term, and is, I think, much better, the effect is much better described by a single term like the Openshaw effect. The effect is very simply stated. It is that the results of any analysis on data aggregated to basic spatial units, so aggregated to countries or aggregated to counties, will change when those basic spatial units change. This is what, in political terms, we understand as gerrymandering, and something that, of course, is on the top of the political agenda in much of the United States right now. But it has its own version, of course, in social science. And here's, I think, an excellent example of what this is about. I'd like to focus on the area in the top left. There are two red blobs in the top left. The one in the state of Montana, which is here. I should turn on my, and those two counties, if I zoom in on the state of Montana here, those two counties are Deer Lodge and Silver Bow counties in the lower left. And the map I showed you, this map, is a map of cancer mortality, 1950 to 1969, by county, and it's cancer of the lungs and throat among white males. And for some reason, those two counties show up very strongly as anomalously high rates of cancer mortality. If we look into this, it becomes very clear that the reason for that is mining. It's mining in particular of copper during World War II. And those two counties captured two very large copper mines and the people who worked in them. Now, if we were to look elsewhere for similar circumstances, we'd find some examples across the United States. But we might also recognize that if those county boundaries had been drawn differently, if the counties had been larger or smaller, if the county boundaries had captured quite different populations, then we might not have observed this anomaly. And in fact, there may be many other examples of similar anomalies across the United States, which this map does not capture. In other words, our conclusions are dependent on the use of the counties as the basic spatial units and on the way the county boundaries were drawn, in the case of Montana in the late 19th century. So here's an example of how the results of spatial analysis depend very definitely on the basic spatial units used in those analyses. Okay, what other principles might we consider to be important? And one, I believe, is uncertainty. That all geographic data are subject to uncertainty. and so therefore are the results of any analysis or inference drawn from geographic data. That's a principle which we often, I suggest, ignore. We often take data, and particularly we're encouraged to take data in the era of big data. We're encouraged to take data on face value and not question its provenance or its uncertainty. But it is always true that data, which are a representation of the world, are not the world. The map is not the territory. And that any user of GIS must be aware of the uncertainties present in the data and the impacts that those uncertainties have on analysis of the data. I'd suggest another very important principle is this, the principle of equifinality, which holds that given any spatial pattern, and of course in geography and in many disciplines that study the Earth, spatial patterns are what we begin our research in many ways from. And equifinality as a principle states that there will always be multiple explanations for the same spatial pattern. If we were to take one of the most famous examples, which is the map that Dr. John Snow made of a cholera outbreak in London in 1854, and that map appears very clearly to demonstrate the importance of a particular pump in spreading cholera. But if we were to take this principle and think about it, we would realize that there are many other possible explanations for that same pattern, many other processes which would equally well explain the pattern. So just to sum up, I think if I could sum up what I've been saying, it is that it is always important to recognize critical spatial thinking, to recognize that what goes on in the mind of the experienced user of GIS and spatial data is something that no machine can perform for you. A GIS may appear to be a very elegant and powerful machine, but it is only the human mind that will deal, for example, with issues of uncertainty, will recognize the open-show effect, will recognize the importance of spatial dependence and spatial heterogeneity. So somehow, and whether this is through the educational system or improvements in the design of software, somehow I suggest we have to come to grips with this fact that the effective use of geographic data depends very much on the experience of the user and the user's wisdom in thinking critically about the data. So I hope those points are useful or helpful. Be very interested in any discussion. I hope I've touched on some of the issues which certainly to me have arisen in listening to the 8 papers in this session. And thank you very much for your attention.
Thanks, Professor Goodchild. And I think this last consideration is very interesting, especially this approach on critical spatial thinking and the reflection you did and share about all the history of critical GIS in the international level. I think it can be a very summarized element, what the machine cannot tell you. And I think this is very important element. I will let the floor, you can, for all participants, you can write a question on the chat, please. Okay.
Here with some questions.
Okay, there is people.
Don't be shy with Professor Goodchild. You have a question?
No, just keep back from.
Please, Salvatore, if there is question in the room, and you can share the microphone, and for Giuseppe and Edoardo, if there is question in the chat.
Massimo, in your introduction, one thing that occurred to me is you were very kind about the 1991 two-volume big book on GIS, which we published in 91, and which had 72 chapters.
Yes.
And we realized afterwards that in that entire 1,000 or so pages, there is not a single reference to the internet in 1991. And of course, the internet in 1992 radically changed the entire perspective on GIS. So whatever I say in response to questions, take with a grain of salt.
No, thanks for highlight this. I think this book is very interesting for two reasons. One, because in these 40 years, now it is easier to do GIS compared to this epoch. It was very difficult. But from the other side, the theoretical model, the geographical model, still the same, also with some changes. I think this during didactic activities, I want to stress this. It's very important because there are some rule, okay, technology, LPAS, etc., but some elements still rooted in a basic knowledge.
Mm.
Okay, I don't know if there is other question.
Yes, there are some questions here from the room.
Please.
Yeah, thank you for an interesting presentation. Having watched the presentations today, the 8 topics on climate justice, as someone who has been involved in spatial analysis for some time, and you're considered an expert and a leader in the methodology and the tools, is there any advice for us who are researching justice in the city and attempting to bridge that gap, like that? The principles that you've highlighted are an excellent reminder for us as we conduct our research on justice in the city vis-a-vis climate. Is there advice that you have, having had the opportunity to see the 8 presentations, anything that you can advise us, to a word of caution or something that we need to, that we have omitted, we should take into consideration?
Sure. One of the first studies I was involved with in the general area of EJ, or environmental justice, was in Los Angeles. And it was an analysis.
It's us.
Us. Why it's us?
Technician.
Are we all right?
So it's
Okay, now yes.
Okay.
Yeah. It was an analysis of the data provided by the Environmental Protection Agency, the Toxic Release Inventory, which is an inventory of every company that emits toxins above a certain level into the atmosphere. And as I recall, there were some 800 of these in the Los Angeles basin. And our analysis compared the locations of these plants to minority populations, in this case, the Hispanic population. And it was very clear that Hispanics took the brunt of the environmental impacts of these industries. What was absolutely essential, though, in pursuing that line of research was ground truth, because it was impossible to distinguish, based on the data, between the 2 possible mechanisms. One was that these plants were deliberately located in areas where they would impact minorities, on the one hand. And then the other was that the existence of these plants had depressed housing values to the point where only relatively poor people could afford to move in. And so that housing mechanism was mixed up with the mechanism of actual industrial location. And the only way to sort that out was to go in on the ground through a series of interviews to look at the actual process by which the sites of these plants had been chosen, to look at the long-term impact of a potential impact of environmental pollution on housing value. So that, I guess, emphasizes the last point I was making, that it's not about the data. The data can be as perfect as you like, but unless the data are augmented by work in the field, by historical data, time always gives us far more insight in these kinds of questions than space does. So in the end, we found ample evidence that the corporations that have been locating industrial plants were picking and choosing their locations very carefully, based in part on data on the housing stock, which goes back to the redlining era of the 1930s and 1940s. So the message is, get out in the field, do the ground truth, talk to the local populations, because data will never replace what we can obtain that way.
Thank you.
Thanks, Michael. We have two questions from the chat. Giuseppe asks how people can use GIS tools to do participative planning. And Cristina, I think is Cristina Capineri. Ciao, Michael. How would you link GIS and VGI with the place-based analysis? And so these two questions, you can start from the question of Giuseppe in the use of GIS in participative planning.
Yeah, I think what we have learned is that there are versions of GIS tools which are a much better match to particular settings of participatory planning. And I'd cite, let's say, for example, GIScience, which was originally a development in Kenya related to election manipulation, but which became useful all over the world and in the United States, where it was very useful to have a technology based on the cell phone and based on place name recognition, which could be used to acquire, accumulate, aggregate geographic data. So I think the answer to the question, the answer I'd make to the question is make sure that your tools match the culture that is doing the participatory planning. And that's not necessarily terribly easy, because much of GIS is designed on the basis of European, North American, first world thinking, particularly about land ownership, and gets into trouble. So I'm thinking particularly of a participatory planning project which took place back in, about 10 years ago in the Chiapas area of Mexico, and which led to something close to an international crisis, because the tools had not been matched to the reality and the culture that they were being used for. I remember experience also in India. This is going back into the 80s and 90s, at a time when India was blocking any importation of high tech in order to stimulate its own industry. And so we had to adapt everything we had to the capabilities of, at that time, Hindustan Computers Limited and their technology. And I think also I'd make the same point about not just about the tools, but about the data. That in a planning exercise, it's important that the data match what the local culture considers to be important to map. And I like to cite there the work of David Mark and Andrew Turk in Western Australia, where they worked with a local Aboriginal tribe and worked on how to adapt mapping practice to the particular needs of that culture and the language. And after all, and I'm embarrassed to an extent that we are having to use English, that you are having to use English, that so much of high tech is unilingual English, and that's unfortunate and needs work. Christina, I think every time we talk about VGI, we talk about place. And I'm thinking then of the distinction between space based on coordinates and place based on names. And VGI is of course far better adapted to a place world than a space world, because we can ask people about places. We can't ask them about latitudes and longitudes. And place-based analysis, I think, is very definitely what we are headed towards. We have now some excellent methods of place-based analysis, thinking particularly of multi-scale geographically weighted regression, and several techniques in the same kind of basket. And we are very definitely headed towards a world of place-based analysis, which is, I suggest, a rational response to spatial heterogeneity. If we can't generalize about the world, then let us focus on places and the analysis of places.
Thanks, Michael. I don't know if there is other question in the room in Bolzano or in the...
Yes. Another question. Thank you very much, Professor Goodchild. And a question, because usually when we make, I don't know, ecosystem service assessment or other kind of assessment, we usually use value transfer or benefit transfer models, no, to take the value, give it to a place, and this value will be transferred to similar places. So in your opinion, this is possible, is a possible methodology, or we have to take very careful these kind of methodologies of value transfer? Thank you.
I think we have to be very careful. And the open show effect is a key there. When you ascribe an attribute to an area, you must think very carefully about how homogeneous that area really is, and whether that area, and how much influence choosing that area has. If I were to ascribe the attribute to some different area, would that change my inferences? So yeah, I think that's tremendously important. I think we are doing much better now in identifying similar places. The task of find similar is something that in the early days of GIS, we never considered important. And it's only in the recent few years that the vendors, QGIS, Esri, have developed ways of executing a find similar question. And it's becoming more and more important. And it's also something that relates very strongly to artificial intelligence and to particularly geo artificial or geo AI. And it's driven in part by the fact that we have so much data. We have layers and layers and layers of data at fine resolution. And so we're now much more able to use a GIS to find similar places. I remember years ago working with the fast food industry and dealing with what they called the analog method, which was that if you wanted to make a decision about establishing a new store, in a particular location, you would find stores in similar locations. And you would base your analysis on how those stores were doing. So if you have an existing store in an area that looks similar, then you would confidently predict that your new store is going to do as well as that one does. That requires some careful consideration of the particular variables that you use when you're defining a similarity. But by and large, I think we are going to be making a lot more of the ability of GIS to find similar places and to make decisions on that kind of basis.